Hey guys, welcome to this tutorial on Introduction to NumPy. NumPy is a library built on Python. It means numerical Python, and it was developed by a Python developer. So it is an external library. It is not an inbuilt Python library. So a library is just a file that contains modules and packages, and modules and packages are just subfiles. You can see a library like a directory, a folder that contains subfolders. So these subfolders are the packages and the modules, and simply all these are they just contain written codes that have been they contain functions that you can use in your code. So NumPy was built to perform mathematical operations, and since we are doing data analysis, we'll be using NumPy, Pandas, SciPy, Matplotlib, and so many more libraries. But today we are going to be talking about Introduction to NumPy. So normally, if we were not using Google Colab, we would have had to download NumPy because it is an external library. It is not an inbuilt Python library. But since we will be using Google Colab, all we need to do, everything has been pre-installed on the cloud. So what we need to do is just to import the library. And to import a library so you can have access to it in your file, you simply use the import function. So you say import NumPy. So we can say import NumPy, or we can shorten, since we'll be using this library and we'll be using submodules in it, we may want to shorten how we imported the name. So we can say import numpy as np. So in our code, we'll be using np instead of having to write numpy. So you can use anything, but the customary name used to import numpy is np. You can import it as ls, you can import it as anything you want, but the tradition is to import numpy as np. So np is just what we'll be referencing in our file now. So we've imported NumPy. Now we can now use all the functions that has been written in this library in our code. So as I've said earlier, NumPy was built to perform mathematical operations, so you have to deal with numbers and all that. So primarily, the major structure of NumPy deals with arrays. An array is just like list in Python. It's just like a list, but it is a more advanced list that you can perform a lot of operations on it than just an ordinary Python list. So simply, to create an array, you just create the variable array. I'm naming mine array, you can name it anything. Then since we imported our numpy as np, you simply just say np.array. So we are calling the array function. So array, then in the bracket, remember, if you want to call a function, you put a bracket, then in it you pass in the argument. Now I want to create an array. So usually the array function takes in one argument, that is the list of the array you want to create. So you can have one-dimensional array, that's just a single row of an array, or you can have multi-dimensional, that is, to have more than one rows and it will have different columns. So here let's just see a unidimensional array. So I can just say 1 2 3 4 5 6. Then we don't have to write print here. You remember in Google Colab, the last statement you write will always be printed out. So but then you can just write print if you want. Print array. So if you execute this, you see we have 1 2 3 4 5 6. So this is a unidimensional array. It's just a single column. It's a vector. So unidimensional arrays are known as vectors. So it's just a single column, and if you want to access the values, you just simply access it normally like a list. You put index of 0, it takes you to the first element of your array. So if you print this now, you get 1 printed out, and the same thing with 1, you get the index of 1, that is 2 here. So you can also do slicing, let's say 0 to 3, to print more than 1. So it will start from 0 and stop at 3. Remember, the upper bound is not always included, so it will start at 0, that is 1, 2, this is 0, this is 1, this is 2, then to stop at this, and this 4 it will not be printed out, so that's why we have 1, 2, 3 here. So you would just when you see it here, it will seem like a list to you, but if we check the type, let's say type of array, you see we have a NumPy array, so it is not a list, but when you see it here, it just appears as a normal Python list, but it's not a list, it's a NumPy array. So this is just a unidimensional array, and it's also known as a vector. Now let's move forward and see more examples with multidimensional arrays. So multidimensional arrays are also known as matrices. They're known as matrices. So they contain more than one column and rows. So let's create a multidimensional array. The same way you create a unidimensional array, that's the same way you create. Let's name this array2, and then np. Remember, we imported our NumPy as np.array. Then I said it takes only one argument. So if you decide to write your numbers here, that means you are creating a unidimensional array. But to create multidimensional arrays, then you have to pass in another list. So this will be 1, 2, 3, 4. So this list now here will be the first row. Then you can pass in another one here. Let's say 5, 6, 7, 8. Then you can pass in another one here. Let's say 9, 10, 11, and 12. So let's print array2 and see the output. So you see we have first row, second row, and this third row. So this is a matrix. It's a matrix. It's not a vector because it has more than one. It is not a single dimension. So if you want to know the dimension of this now, this has 3 rows and then 4 columns. It has 4 columns. So we can check the dimension by just say array2.shape. To check the shape, you see we've printed the array out, and the shape is 3 by 4. So it has 3 rows and 4 columns. This is the dimension. It has 3 rows and 4 columns. So it has 2 dimensions only. It has 2 dimensions. That is just rows and columns. So this is a bidimensional array. We can have more than 2 dimensions. It can be a shape of 2 by 2 by 2. Let's look at an example of that. Let's create an array of 3 that will have 3 dimensions. np.array. Remember, you have to put in this list. It's the only argument. If you pass it in like this, let's say 2, 3, then you put another list here. That means you are passing more than one argument. This will give you an error. Let's print array3 now. You see it will give you an error because you see data type not understood. So it takes in only one argument. So you pass in that single list first, then inside the single list you pass in your values. So let's create an array that will have a dimension that will have 3 dimensions. So let's have one row here. Let's have a second row. Okay, let's have just 2 first rows. Then in this first row we should have another row. Let's say 1, 2 here. In this second row, let's say we have 3, 4. Don't get confused. You understand it by the time we print it out. Then we have 5, 6 here. Then we have 7, 8. So let's print array 3. You see we have. So let's print the shape. So when you look at this now, let's look at it first before let's try to deduce the shape ourselves. So when you look at this array, you see that this is the shell or the house. Then it has one here. This is the first row and this is the second row. So this first dimension is 2. It has 2 rows. Then inside of this first row, it has 2 rows again. 2 rows. And then inside of this second row, it also has 2 rows. And then in each of these rows, we now have 2 columns. So this dimension will be 2 by 2 by 2. That is 2 first rows, then these 2 inner rows, then these 2 columns. I don't know if you understand. Maybe you should change, let's change the number of columns to 3 so that you don't get confused. Let's say 9 and let's say 2. Okay. Now after we print the array, let's print the shape. Array 3 dot shape. So now you see we have 2 by 2 by 3. So this it has 3 dimensions and this one has 2 dimensions. So there are different ways you can create arrays and with different dimensions, with multiple dimensions, depending on what you want. So that is all about creating arrays and all about matrices and vectors. I hope you understand. If you have any questions, please drop it in the Slack channel.